Hello and welcome to Matrix Live, the show to tell you what's happening in Matrix, the open protocol for secure and decentralized communications. A few episodes ago, we talked about ElementX, the project to make Element iOS and Android use the Matrix Rust SDK. We said back then that the strategy for Element is to go full steam on the Rust SDK, not to follow a hype or for the sake of it, but because it makes sense. Matrix is an advanced protocol, and in the industry, we can often hear, "Don't write your own crypto." This is because writing cryptography libraries is difficult and you want it to be as tested, used and debugged as possible. The more people work on a common library, the more bugs are fixed, the better the quality of the library is. The Rust SDK applies the same principle to Matrix. It's about developing a feature once and getting as many people as possible to contribute back to make it a battle-tested library. This is also how to get more value out of the Matrix ecosystem. Competing products would not differentiate by re-implementing the protocol, but by having a fancier UI or a more focused use, a different approach to user experience. What happens behind the scenes doesn't matter much to the user. My guest today is Ivan, engineer in the Rust team at Element who worked on NodeJS bindings for the Rust SDK. That's one set of complicated words, so let's talk about it in more detail. Ivan, welcome. So far, I have been talking about the Rust SDK, but is it fair to call it a Rust SDK?
So I suppose it is not really fair to talk about a single Rust SDK, actually. So it is a set of crates, so you can understand that as a set of libraries for Rust. And each library tackles specific problems, like we have the Matrix SDK crypto, which is no-network I/O encryption state machines that can be used to add Matrix end-to-end encryption support for a particular client. But on top of that, we have a very high-level client library called Matrix SDK, which is a battery-included client for Matrix specifically.
All right, makes sense. And I've been talking about Node.js bindings for a Rust project. Can you remind us very briefly what binding is?
So we are very lucky to work with Rust because it can be embedded in various languages and environments. And so a binding in this case is to integrate or to embed the Rust SDK inside another technology. So for the context of Node.js, it is writing a Node.js API that is actually embedding the Rust SDK.
All right, so being able to call Rust code from a different language, such as Node.js, are the bindings covering the entirety of the SDK, or only certain crates?
So for the moment, we only target the crypto crate. So for Node.js and also WebAssembly, which are two bindings I'm working on, we also have all the bindings, more generic ones. But it's for another Matrix Live episode.
All right. Why creating the bindings on the Rust SDK? Who will use it?
So the goal of having the Rust SDK is to have a single implementation that can be used and reused by a lot of consumers. So not client, but many application or languages. For instance, the Element iOS or Element Android application can use the Rust SDK through bindings. And for the Node.js bindings, the users are primarily bridges, so people who want to write boats or bridges to other networks.
Right, and as a developer, if I don't necessarily want to understand everything that's happening in depth in the stack, how are things going to look like for me? Am I going to call a Node.js module, which is going to call the Matrix Rust SDK behind the scenes?
Exactly. So it's pure Node.js. You don't know Rust SDK or Rust is running behind the scene. It's absolutely transparent. So you don't have to manage anything. Probably if you have a very particular installation, you may be required to have the Rust compiler, but we are working to provide the best developer experience as possible. So it's very likely to be totally transparent for you.
Okay. One thing that I'm wondering is the bindings. Isn't it something that's purely generated automatically? Is there some business code inside it, or did you just press a button, or did you do a bit more to get the bindings happening in reality?
That's a good question. So in theory, we could be able to generate the code automatically, but practically it's very different. So we have to handle a lot of very particular things. Like for Node.js, we have to handle the garbage collector, for instance, or the types from Node.js are more or less dynamic, contrary to Rust, where they are very strict and static. So you have to map one word to another. So it is something that is kind of hard to generate automatically. We also want to have full control of it. But there is no really business code in it. It's really a mapping from one word to another. So there is no particular Rust code. It's really the Rust SDK with mapping to Node.js or another word like WASM or I don't know.
All right. So if I summarize it with my very poorly technical person words, you would be able to generate bindings that are of poor quality automatically, but you are spending a little bit of time to make the bindings of better quality to make them easier to understand for a Node.js developer?
Yeah, so this is the case for Node.js because the language is dynamic, just like PHP or Ruby or anything, or other similar languages. But this is not the case for Swift or C or Java, for instance, where it is easier. By easier, I don't mean it is simple, but but it is more straightforward to generate automatically things. And this is what we are doing with UnifFI, for instance. So we generate automatically FFI bindings. FFI means foreign function interface. So this is the way C can communicate with other languages, other worlds. And so we use it to talk with Swift or Android through Kotlin. Sorry. So in this case, it can be generated automatically, but for Node.js, it is more particular.
All right. Talking of quality, I said in the intro that one of the points of going full steam with the Rust SDK was to have a battle-tested library. Are you writing tests for the bindings too?
What is a test? Yeah, of course. So we have policy for that. So we have a great code coverage for the Rust SDK, and we spend particular attention to have everything battle tested in there. And that's the beauty of it. If we write bindings, we just care about testing the bindings itself. So the boundary between Rust and, for this particular use case, Node.js. But we don't have to test the entire API with all each edge cases or test cases, etc. We just focus on the binding itself. So that way we are sure the binding works and the underlying behavior is ensured by the test of the Rust SDK itself.
Right. I'm sure I'm going to shock many people here, but Element is a commercial company. You are working for Element. I guess you are not just doing those bindings for the sake of it. Do you know if Element or the Matrix.org Foundation has projects which are going to use the Node.js bindings?
Yes, more or less. So we can't say everything publicly for now, but what we can say is the biggest target here is bridges. So we have something we call end-to-bridge encryption. So if you have a network that want to talk to Matrix, then you can write a bridge that will decrypt the message from the Matrix network and then forward it to the targeted network. And so in this case, Node.js bindings is suited for that.
Right, so this is, I think, what people call end-to-bridge encryption, because it's not entirely possible to get end-to-end encryption with two different encryption. So you need to break it at some point, which is the bridge. You mentioned a bit earlier, I heard the word WebAssembly. Do we have WebAssembly bindings? If yes, can you remind us what WebAssembly is and why having WebAssembly bindings and Node.js bindings?
So WebAssembly, or WASM for short, is a new technology aiming at, yeah. So this is a new executable binary format. And so it came from JavaScript, then ASM.js, and then WebAssembly. So you can run it everywhere, like in a client or a server, Edge, or I don't know, or even in a browser. So it is truly universal for that. And so the idea for Matrix is to be able to first and right now to compile the crypto SDK, the REST crypto SDK into WebAssembly. So it was working, but we had no API available publicly. So what I have done is to start implementing it. And so the goal is to have, so right now we are able to use the REST SDK inside the iOS and Android Elements apps, and the Element Web is missing. So sorry, the Element Web application is missing. So the goal is to replace the crypto module inside the Matrix.js, the JavaScript SDK, by this WASM binary that came from the REST. So we have REST SDK compiled to WebAssembly used inside the JS SDK so that we can embed it inside the Element Web application. So in this case, we will have a single crypto crate, so a single crypto implementation that is going to be used by all the Element applications.
Okay, fantastic. So in short, we will have the Node.js for everything bots and bridges, so mostly server-side, and everything WebAssembly for clients using the JS SDK, and all of it using the same implementation in Rust behind the scene.
Exactly.
That's cool. Very cool.
So we would have been, it would have been possible to use the WASM module inside Node.js because Node.js supports WASM through V8, but it has some particularities, and the speed is not the same. The performance is not exactly the same. So yeah, so you have the choice now.
All right. Are you done, or are there still parts of the SDK that you need to get bindings for?
So the Node.js bindings has been merged a couple days ago, so it's very fresh and new. We are waiting for users to try it. Documentation is online, everything is online, battle tested. We are just working right now on distributing precompiled Node.js module, so that the experience will be totally transparent. And for WebAssembly, the project was on track, and then we had to stop it to shift our priority to Node.js, and now I'm working back on WASM. So it is usable. We have some proof of concept implementation inside the Matrix.js SDK already, and it works. We don't support all the features for now, but I'm working on it. So as soon as someone is asking a new feature, I'm implementing it. And yeah, we are going fast. So maybe in a couple of weeks or probably months, I don't know. I hope not. Everything will be online.
All right, excellent. Sidetracking a bit, you mentioned, I'm going to be a bit cheeky here, you mentioned on Twitter that you got more than 100 job offers. Why working on Matrix and why joining Element?
So it is true that I'm working for Element since a month only, or no, 6 weeks to be honest. Why Matrix and Element? Because I wanted, when I'm working for a company, I mean, I want the company to have some values and to provide something useful for the world. And communication is truly essential today, and in particular, encrypted communication. So that's why I have decided to choose Matrix. And it had good challenges also. So
this answer makes me super happy. This is the reason why I decided to join Element 2. Although I'm not providing the same value from the technical side. This is not where I work the most. Do you have any final thoughts to conclude the episode?
Yeah, Matrix is a great technology, and be ensured the entire company is working hard to provide the best client experience as possible. So stay tuned.
Awesome. So thank you, Matrix Live. I hope you enjoyed the episode and you learned more about the Rust strategy and what's coming in the bridges and clients world. And I see you next week. See you around, Matrix Live.